Morning, dear friends. As what we'll be discussing today, and that's the topic is on flaps. Now, I am drawing your attention to a Cessna 206 airplane. You could see that these are the aileron, right? And this is the flap. Okay? See, we are now putting the flap down. What is happening? Please look here. Look here. This aerofoil now locally is having a camber. Okay? Could you see this? By putting the flap down, it is adding camber to this section. And we know cambered aerofoil will produce more lift. So that is how the CL max is increased, the lifting characteristic increased, so that you can reduce the takeoff speed. During takeoff, the pilot will be setting the flap deflection by, let's say, 10 degrees. So kindly deflect the flap by 10 degrees. You could see that flap has been deflected down by 10 degrees. Okay? Now there is another angle also you can deflect it, which is 20 degrees. 20 degrees. And during landing, as I am telling, it goes to the maximum, so it will go to 40 degrees. And it's very evident now, you see, during landing 40 degrees when you are putting, actually primarily we are trying to increase the drag. That helps in braking the airplane to a shorter distance, because this is also important that we need to have a shorter touchdown distance, right? Please understand, when I say by putting the flaps down, we are increasing the lift, but that is at the cost of drag. So that is why in takeoff, we have to put a lot of throttle, almost power on. And the CL by CD max reduces, right? Okay? So this is the primary function for a flap. And now we'll go to the classroom and we will discuss about the theory behind this flap and what types of flaps are there. How to maximize the flap's effectiveness, and how the history of aviation has seen such development and what is practically being used now. I have demonstrated you one simple flap which Cessna 206 is installed with. So topic I am giving as flaps. What is the purpose of flap? Purpose is I want to increase CL max. Typically, if we take a normal wing, the CL max is in the range of 1.2 to let's say 1.5. A little bit high, but yes, you can customize it. As a designer, we do not take more than 1.2. So preferably, I will prefer the number 1.2 because yes, a schematic number. Now, there is a flap which is nomenclatured as plain flap, which is nothing but this is the same aerofoil, and then this portion can go down. Please understand, this is the wing. Okay? If I draw the top view, this is the wing, center line. Let's say this is the fuselage. This is the tail here. Oh, tail here means it will not look like this. The tail here. Okay? The horizontal tail. When I'm saying flap, this portion, this is aileron. Okay? This is used for what? I demonstrated that if I put this aileron down, that means camber of my right wing has changed, so more lift here, so it will give a bank, left bank like this. However, we are talking about this flap. This is the flap. So if I take this flap area, the moment I put, similarly flap is here, the moment I do this, only these two flaps, they are going down. Okay? Understood? So locally, the camber of this portion of the wing is changed, and that portion will be giving more lift, that will enhance the CL max value. Okay? Is it clear now? And why CL max has increased? Because by doing this, you are seeing that yourself, it has added camber. And we know for camber aerofoil, let's say this is plain flap. Okay? And for camber, for the moment I put a plain flap, since it has changed the camber, it will be something like this. And there is an increase in CL max. Typical number, if I give you for plain flap, the CL max will go from to lie between 1.6 to 2.2. These are all a representative number, right? We can customize, okay? So this is typically the principle of plain flap. Our Cessna 206 is having this plain flap, and I have demonstrated I can deflect that plain flap for 10 degree for takeoff and 20 degree sometime, but for full maximum flap deflection, I am sure that now I have touched the ground. That is primarily used for increasing the drag to reduce the touchdown distance. Okay, so this is plain flap. So what is the principle being used in this plain flap? That to increase the CL max, use the concept of adding artificial camber to the whole wing. But we also understand it doesn't change the camber of this portion or that portion, only changes the camber for the area which has flap installed. And the flap is not full for the wing. Part is only flap. At the end, whatever we have, these are called aileron. This is very, very important. Okay. After this flap concept, there was another effort, to again change the camber by a different thought process. What was done? You take, this is the wing, and make something like this, and it's called a split flap. You understand what is it? It is, otherwise it is touching this portion, and whenever required, it will split from this portion. What is this doing? This is also changing the camber. But this was also used, and for some time it was also popular. But remember one thing, these designs have improved with a primary aim to increase CL max. But these designs were benchmarked after addressing a question, are you having appropriate CL by CD max or not? So we have to see in totality, not only increasing CL max, but also see what is the drag penalty, right? And with that in mind, every design has some limitation, and that is how this design of flaps has evolved today. So from split flap, there is a concept which is very popular. People are using it, Fowler flap. What is the concept here? Remember, I told you, if I want to increase CL max, what are the options I have got? I have, option is camber. Change the camber. But if you want to increase the V-stall, I have an option, not only you increase CL max, but also reduce wing loading. May it be low, doesn't matter. Slight increase is good enough. So that concept is used in Fowler flap. What is done? It is like this. This portion has two motion. One is it will go this side and then turn this side. Are you getting the point? So if I really draw it correctly, it will go here and do it like this. Is it clear to you? If it is not clear, let me draw it again. This is very important, so you need to understand what a wonderful way our designers, aeronautical designers have evolved this flap, and still they continue doing it. So we are talking about Fowler flap. It is basically, the concept is based on split flap, but now this unit has this motion as well as rotation motion. It is just not splitting like this. It is moving backward and doing like this. So what has happened in the process? It has increased camber. Also it has increased area of the wing. And area of the wing it has increased means actually it has locally reduced wing loading. And you know Vstall will decrease if I decrease wing loading. Please understand, with this Fowler flap, the two motion, one is going like this and then rotation. By rotation, it has increased the camber, so it has helped CLmax. By going backward, it has increased the area, so wing loading has gone down. And you know that Vstall goes down if CLmax increases, it also goes down if W by S decreases, right? So increasing the area, W by S has gone down, so it has also helped in decreasing Vstall. What a wonderful design. Simple, elegant, right? But you should also appreciate this idea and this idea have to be complemented to each other, okay? And that is what is the Fowler flap. Let us talk about double slotted flap. In double slotted flap, that if I draw the diagram, it will be very clear to you. Please understand this new term, slotted. Why slot was necessary? Before I go for this, let me complete this part. The CLmax up to 3 achieved. Okay? These are numbers I repeat again and again. These are some representative number, right? You can Google and find out what is happening in different configurations. Now I have introduced another term, slotted flap. That is, this portion, concentrate on this portion. These are slots. Can you guess why this slot is there? Let us go back. And you remember that as angle of attack increases, right, we have seen that the pressure here, P3, P2, P1, because area is increasing, the speed is decreasing, so static pressure will increase. So there is a adverse pressure which will discourage the fluid motion forward. Moreover, there is a friction. So there is something called separation. In language of flight mechanics, that means I will not be able to use beyond that angle where flow separation starts. So the flight mechanics man, I will ask a question, do I have a mechanism to ensure that this separation is delayed? That is, I can use further angle of the flap. By simple common sense, what does it mean to us? If this friend of ours, the boundary layer, is having a divide of energy, I supply him energy. So what I do? This is some fluid with high energy, I pump into this area. Okay? So that energy will revitalize this fluid particle, and this separation point from here, it may come here. Effectively, I can further increase this angle. Okay? Is this clear? Now, with this understanding, come back here. Here there is slot. This slot means if you see the fluid particle, they will come like this, few will go like this, few will go like this. Now, if earlier the separation point was somewhere here, but now this fluid particle, they will energize locally this fluid particle here. So their separation will be delayed. So this flap will be very effective. Further, what happens? Further, I have given another slot here. So now fluid particle comes from here. So this also becomes effective. So I can go on putting such multiple slotted flaps. What is the difference? One is I put multiple slotted flap, and one could ask me, why don't you put a single flap like this, same angle? Answer is obvious. If I put a single flap like this, flow will separate. So I have separated this in 3 or 4 multi flaps and provided a slot so that local separation is delayed. And this is a very efficient way of increasing CL max. Okay? And with this, you can get anything up to 3.5 CL max. I'm just mentioning few types of flaps, and as and when required, I'll be more specific on a particular type of flap for a particular airplane. There is another type of flap which is also has drawn a lot of attention. Just for completion, I am mentioning that Kruger flap, and that is something like this. Please understand, this portion will be inside the wing, but it's not a part of the wing. So it is the leading edge. Okay? So it will come out and change the camber, and you will get lift, and when it's airborne, this will go inside. However, this will not become the part of the wing. That's more important. So many things we have spoken. Summarize, we need to understand few things very, very clearly. Why we were discussing about flap? Why flaps? Question is this. Our aim is we want to reduce this takeoff distance. Our aim is to reduce it. Reduce it means I need to reduce Vstall. How to reduce Vstall? One is increase CL max or decrease wing loading. How to increase CL max? They are coming flaps. And what is the concept behind it? Change the camber or increase area so that W by S decreases. It's typically Fowler flap. Okay? And in flaps also you have seen slotted flap. Why slotted flap? Because by using slotted flap, we can further put the flaps down, and it will not face the problem of separation, or the separation points will be delayed. And in that, we have put multi flaps like this instead of putting one flap with such a large angle, because I know this fluid particle coming from here will energize this, so this stall will be delayed. Similar thing will happen here, and that way I can efficiently design a multi-aerofoil flaps. Okay? And that is how we are trying to increase CL max so that Vstall is reduced and we have shorter takeoff distance. Okay? Thank you.